Hello, class. My name is Anna Lang.
And I am Sergio Gonzales, and this is our planetary exploration project on Io, one of the moons of Jupiter. Io, a journey into the world of volcanoes. We have not had a specific mission that is for specific research of Io. All the images and data we have are from other missions flying by on their way to their main objective, that being Jupiter, Saturn, or even just for interstellar space research. We must fund a mission to visit Io so that we can understand how Io is actually dealing with being an electrical body generator for Jupiter. When Io interacts with Jupiter's magnetosphere, it creates a connection of electrical current of approximately 40,000 volts. This helps double Jupiter's magnetosphere while allowing itself to not drift away from Jupiter. We must also find out why Io is not cooling down even though it exhausts a lot of heat constantly, due to tidal heating, which is being pulled by Jupiter and other moons like Europa and Ganymede.
Some basic information about Io. Io is one out of 67 of Jupiter's moon that is also inside its magnetosphere. Io is unique for being a volcanically active moon in our solar system, and reaching Io for research purposes will be tough but could satisfy our curiosity. With it having magnetic fields that we believe that contains an iron core just like Earth, Io has one of the tallest mountains in our solar system with over 400 active volcanoes that can constantly exhaust fine particles into space.
Io is actually just a tiny bit larger than the Earth's moon. Io is 5.44 AUs from the Sun, as it is orbiting Jupiter. Io is tidally locked to Jupiter, therefore always one side faces Jupiter. It takes 1.8 Earth days to orbit Jupiter, while it takes 12 years to orbit the Sun.
Some similarities Io have to Earth. Io is fairly small compared to Earth, but is bigger than our moon. The closest thing that we have in common is basically the iron core that I mentioned earlier, and it is made out of silicated rock, which is what makes Earth's crust.
This is an illustration of what it would be like to stand on the Io surface. Of course, leaving out the magma river and radiation and sulfur dioxide atmosphere. We know that Io is a poor candidate for life because of the volcanoes and magma rivers around this moon. But if we could send a probe and look for the surface composition, and could decide to test magnetic fields, compare them to Earth, we would be one step closer in figuring out the truth of Io.
How would we get to Io? We would have to fly by a spaceship, but honestly, it is humanly impossible for us to survive 34.5 million miles from Earth to Io. Therefore, we would have to send an automated spaceship in our place.
Humans would unfortunately not be able to colonize Io, for it is an inhospitable planetary object full of magma and many active volcanoes constantly reshaping itself, again due to tidal heating. Io would not be the best candidate for terraformation, for we would need to find a way to shield ourselves from the radiation from Jupiter, and we would need to find a way to stop this tidal heating. There are many challenges, therefore it seems a waste of resources to terraform in Io. Again, the constant shocks of radiation from Jupiter are the main danger.
So, what are some resources found on Io? Unlike most moons in our solar system, which is mostly composed of water and ice, Io is primarily composed of silicated rock surrounding a molten iron, or an iron sulfate core. Most of Io's surface is composed of extensive plains with a frosty coating or sulfur and sulfur dioxide.
Io needs to be explored to see why it has not cooled down, even though it exhausts a lot of heat, constantly due to it being reshaped. Io has molten oceans, and finding this evidence is key to proving that these oceans mix with the solid rock to create offset areas around Io. Some are more volcanically active than others. Having a dedicated mission for Io would not benefit us colonizing it, but it would benefit the pursuit of knowledge. Io is a great challenge, therefore we must look for these answers. Thanks for listening.